mouse, right? So now you can tell the power. Now, you say, well, what you invent here is not a mouse. Well, call something else. But it completely satisfies the functional requirement. And the reason I can come with such a drastically different design is because I did not describe my design using the term mouse. Because if I say that, I will never end up with this. I will end up with just a mouse. The mouse may be big, small, and maybe heavy, maybe light, but it's mouse. Because I did not use the term mouse, instead I'm focusing on the function, what it tried to do, rather than behavior, I am able to come up with many innovative ideas. This is just one. And those innovative ideas will be a good case for you to file a patent. So a lot of time people will say, how do you think out of the box? We always say that, right? Think out of the box. How do you think out of the box? Well, the easy answer is you begin your thinking from outside the box. What do you mean by that? Don't describe the box. Describe what the box is supposed to do. Because once you describe box, you're already being boxed into the box. So do not describe this as noun. Describe this as verb, to hold, to point, to click. Once you have these things, then you can realize that by different kind of simple module, and because you have keep them independent of each other, in other words, they can be put together in any way they want, and therefore you will have an innovative design here. Okay? Any questions?
Yeah.
Any questions from?
Yeah. Could you just repeat that last part about how to think outside the box? You said don't mention the box, but what it does. Can you just clarify that?
Okay. What I said is we all wanted to think outside the box. The box is the constraint. But if you start to describe your solution by using the word box, you're already being constrained. So what you need to do is, rather than saying a box, you need to say what that quote-unquote box allowed you to do, not allowed you to do. So you need to say the requirement of that box. You need to describe the functional requirement of that box instead of describing that box. In other words, you need to have an abstract thinking. So my point is, in order to think outside the box, think abstractly. And the way to think abstractly is to think in terms of functional requirement rather than the physical embodiment. Okay? Any questions?
Hello.
Go ahead.
I'm from PKU. And when you talk about abstract thinking, the requirement is concrete. Is that right?
Okay. Very good question. To think abstractly, the requirement has to be specific enough, not concrete, because concrete things only refer to the physical object. So I would say the requirement has to be clearly defined. Okay? Other questions? Okay. Let me show you another way to think abstract, okay?
Excuse me, can I ask a question?
Yes, go ahead.
And I'm Monkey from NTU. And I want to ask that Professor Lu just asked us to think of the functions requirement instead of the behaviors. But I want to ask the guy whether this kind of thinking way is only focused on the manufacturing way or not. Because, for example, if I want to help an activity or a project, then the functional requirement may be an interesting incentive and a place where I can help these activities. But in my opinion, executing an activity is to integrate the existing resource. So if we just focus on brainstorming on the functional requirements, then we cannot just link it into practical.
Okay, very good. The question was, I used the term function and behavior. Those two terms are commonly used in engineering domain. Therefore, the student question is, am I only refer to innovation in the manufacturing process, or engineering product? The answer is no. Okay? It is very important you understand the term of function and the term of behavior is a generic term. It does not necessarily refer to an engineering system or part. Say, for example, we often call your job function, right? So you take a job, you have a job function, right? What is a job function? It's described on a piece of paper, right? It's not a physical thing. When we say you want to do a project, right? The project has certain functional requirement. When we say the behavior, that means you have a job requirement, you will carry out the job, then we will evaluate your performance. That outcome is the behavior. So when I say functions, I refer to anything, as long as the things are something called artifact. Artifact doesn't have to be a physical thing. An organization is an artifact. A project is an artifact. Artifacts are man-made things. It can be real thing, it can be a conceptual thing, it can be software, it can be hardware. So, when I say function, when I say behavior, I do not refer to engineering or engineer part. Instead, I refer to anything that is called artifact. The man-made things, not the natural things. Okay? Any other questions?
Professor Lu.
Hello.
Yes, go ahead.
I'm Jerry Wu in NTU. I have some question about the design parameters and the usage configuration at slide 15 page. Page 15. Yeah, I cannot understand the position and the direction and the ranking of 1 and 2 and 3 because I don't know how to use this ranking to link in the configuration. For example, I didn't know why.
What do you mean by ranking?
For example, because the first configuration A is 2, 1, and 3, but the configuration D is 1, 2, and 3, 2, and 1. I cannot understand why they put this ranking. For example, I cannot understand to the configuration B why the 1 is upside down.
Oh, okay. Let me explain these things more clear. Okay. Suppose this is a configuration A, right? Configuration A has 3 modules. These 3 modules, because I designed these 3 modules to meet 2 things. One is they are independent of each other, which means I can unplug them, I can plug them anywhere I want. Number 2, I designed them to be the simplest one possible, which means that if I need other requirement, I can add more later. But at the beginning, I want it to be very simple. So the first configuration A, say for example, I decide to put module 2 at the front. I put a module 1 upside down, and I have a joint to put them together, just like Lego, right? I join them together. Then I put the last module 3 at the end. Now, if you put these 3 functions in this particular order, if you look at, this is your mouse, that's exactly a mouse. Correct? Because you have a button here, right? You have a ball. The ball can be a mechanical ball, it can be a laser module, right? Again, whether it has to be a mechanical ball or laser module, that's a later question. And then you will have a body, a block here to hold. So, although the configuration A do not look like a mouse, functionally speaking, it is a mouse. Okay, because each module is independent of each other, therefore I can tweak each module anywhere I want. So configuration B, what I do is I rotate the first module by 180 degrees, which means that that ball now becomes the top, right? So what I have now is I have a button. Here. Then I have a ball here, which I can use my finger to rotate and will move the mouse, right? Then I still have something to hold. Now, this will then, functionally speaking, become a trackball, right? Functionally speaking, it may not look like trackball. So, in other words, something very interesting you probably haven't noticed. any mouse, if you use upside down, trackball. You said, no, I never thought about that. Well, because you never thought about function. If you thought about function, that's exactly what it is. So any mouse you lift upside down, or certainly the laser mouse is tricky, but if it's a mechanical mouse, imagine you have a mechanical mouse, right? You just put upside down, what is it? That's a trackball. It's a trackball, exactly a trackball. Certainly, you have to optimize that shape and make sure this is comfortable, but that's a different thing. That's a behavior thing. Okay. Now, let me do another one, which is this configuration C. Configuration C, I will have a support at the bottom. I will put the middle module, the module to the click in the middle, and then I will have the top. I can use my thumb to move that ball. What is that? That is actually a joystick. Well, certainly I need to further optimize this and to make it look nice, but that's a later story. It's a later thing. Now the reason I can do that is because I have already made each of these things do one thing, nothing else. They're independent of each other. Okay? Then, if that's the case, I flip these things 180 degrees. I have the ball there, so it becomes something I can move. If I move it on a tablet, and I can trace the coordinate, I can know the X, Y, Z, and then I can click. That becomes a stick mouse. Now, I am sure you can have configuration. This is A, B, C, D. I'm sure you can have a configuration E, F. Go back home and try to see whether you can do that. Because that can go on. Well, certainly some of them gets impossible, but you can continue to expanding configuration E, F, G, H. And they all mouse. And they all input devices because they satisfy the functional requirement. Their physical embodiment can be very different, but the functional requirement is the same thing. Okay? And you say, well, why? Who would need this Lego mouse? Let me tell you, I will need this Lego mouse. Why? Because the current way of designing mouse is such that we all want to make the shape very comfortable. Because our belief is if it's a comfortable shape, you will not have we call repeated stress injury. Repeated stress injury, right? But you know what? Because the shape is so comfortable, I will tend to use it exactly the same position day and night. I end up having a stress injury. So what I did before we have this Lego mouse is I actually have a mouse, trackball, and joystick. Every month I switch. Right? Because then I can exercise different part of my muscle. Every month I will switch. This Lego mouse, I end up only need to carry one set. I don't need to carry three things. You see that? I don't need to carry three things. I only need to carry one set. Because depends on which day I am, I can configure differently. I don't need to carry a separate mouse, trackball, and joystick. I just carry three modules. They can be put together differently. Any questions?
Excuse me, from PKU.
Yes, go ahead.
Yeah. All these configuration have the same functions. So why will customer